So let's look at example 5. It says George looks south and observes an aeroplane at an angle of elevation of 60 degrees. Henrietta is 20 kilometers south of where George is, and she faces north to see the aeroplane at an angle of elevation of 75 degrees. Calculate the distance of the aeroplane from Henrietta's observation point. So let's draw a diagram to see how it looks. So on the ground we have Henrietta and George. So George is here, Henrietta's here. So we're assuming that this direction is north and south. Somewhere along we have the aeroplane, which we'll label P. So at this point we have the aeroplane. So George looks up to see the plane. Draw that again. So the line connecting George and the plane, a straight line. Let's do this. There we go. Hopefully you're using a ruler. So the angle of elevation from George to the plane, so elevation looking up, so that's 60 degrees. And then let's use a ruler again, connecting Henrietta onto the plane. There we go, straight lines. The angle of elevation from Henrietta, of Henrietta to the plane is 75 degrees. So this here is 75 degrees. What do we want to find? We want to find the distance of the aeroplane from Henrietta's observation point. So x, this distance here, is our distance of interest. So let us define our variables. So let x equal distance from Henrietta to the plane, and in brackets our units, which is in kilometers. So let's, I forgot to label something really important. Henrietta is 20 kilometers south of George, so the distance between H and G is 20 kilometers. That is super duper important, right? Because otherwise we won't have enough information to figure out what we want. So, okay, based on what we know, well, we want to work out x, and the triangle we have right now is not right angle triangle, so at the moment Pythagoras and SOHCAHTOA can't directly apply. So let's see if we can use a sine rule. So our distance, our length of interest, is opposite the 60 degrees. If we knew what the distance from P to G was, then we could immediately use a sine rule, because then we have the 75 degrees and the corresponding side length. But we don't have that. Instead, we have the 20 kilometers, which is the corresponding side length of angle P. So if we can work out what that angle P is, then we can apply the sine rule with that angle P in 20 kilometers and x and 60 degrees, because they're the corresponding sides and the angles. So, well, can we work out what that green angle P is? Well, yes, because total sum of angles in a triangle is 180 degrees. So we can work out definitely what that green angle is. So angle GPH, so our angle of interest is squished in the middle, labeled squished by the other two vertices, G and H, is 180 degrees minus 75 degrees minus 60 degrees, because sum of angles in a triangle is 180. So make sure you put degree symbol, otherwise it's assumed radians, and make sure you justify why it adds to 180 degrees, because using the symbol. So if you subtract all that, that gives us 45 degrees. So the green angle is 45 degrees, and that's opposite the 20Ks, and the 60 degrees, which we know is opposite our side length x, which we want, so we can directly apply the sine rule. So make sure you write down using sine rule. So default formula, A on sine of a capital A, because it's angle, is B on sine of capital B, because that is an angle as well. So it doesn't matter which is A, which is B, no, as long as it's a side and its corresponding angle, then you're all good. So let's say x is my A, side length x, The corresponding angle is 60 degrees because that's the opposite side, that's the opposite angle. And the other part that we know is 20 kilometers. That's the distance over the corresponding angle, which is 45 degrees because we calculated that above. 60 degrees and 45 degrees are our exact values, so let's evaluate that. So x over sine of 60 is root 3 on 2, and sine of 45 degrees is 1 on root 2. So let me just go to the sine because I'm out of space. That tells us 2x on root 3 equals 20 root 2, because when you're dividing by a fraction, you flip the bottom guy. We're trying to solve for x, so let's rearrange. So 2x is 20 root 6, because root 2 times root 3 is root 6. And so x is half of that, which is 10 root 6. Check, can we simplify root 6? No, that's all we've got. Calculated distance, so it's 10 root 6 kilometers, or if we're trying to approximate using a calculator, that's approximately 24.49. So Senna's conclusion, therefore the distance of the plane from Henrietta's observation point is exactly 10 root 6 kilometers, or approximately 24.5 kilometers in distance.